Dear Convo friends, I'm really happy to announce that Cohort 6 of my course GenAI Design for Conversations and Content is now open for enrollment. Yesterday I finished teaching session 3 to Cohort 5, and since it's my favorite session about RAG, I thought why not give you a little preview of some of the things that we learn together and how I teach. Because I think it's really important that we not only learn how to build and design GenAI bots and GenAI applications, but I also feel it's important to understand a little bit of the technical background without, completely deep diving in all the technical intricacies, but having a conceptual understanding of how things work. Well, first of all, I really enjoy learning that kind of stuff myself, and I feel it kind of deepens my understanding and informing my design work. Second, I feel it also makes you a better conversation partner for your developers, your machine learning experts, and basically anybody who works with you in a more technical space. And third, and probably most importantly, it helps you to troubleshoot your own solutions when they're not working to the way you expected them to work. And especially with RAG, there's quite a few things that can go wrong or that might, work in a different way than you expected it to work. And to understand where that might be caused and what you can do about it really helps you. So typically how I teach this is by going through the technical background on a more conceptual level. So basically I explain, hey, we've got a document, can be, Word, PDF, but it can also be JSON or code or a website or Excel. But if you want to talk to a document through your LLM, you need to have a document and you need to have that in your system somewhere. So we take this document, we upload it, and we extract the text. And there's typically a few things that happen there, like tokenization and a concept that might sound familiar to you already, chunking. Because once we've extracted this big text, and I typically use the EU AI Act as an example because it's just a beautiful example of a very large document where basically everything is relevant, 200 plus pages, almost 300. Well, that's going to be a bit hard to process as one big blob, right? So typically what happens is we take the text of that document and we split it into smaller chunks. And that can happen in various ways, from really intelligently to rather basic. But it's important to realize that at that point, it still contains text. And LLMs, large language models, contrary to what their names make believe, can't really handle language. So they can't read text. The thing that they can read are numbers, and more specifically, vectors. So the next step is to take all these chunks and convert them into vectors. And this is what we call vector embeddings. And we use an embedding model to convert document chunks into numerical ranges that are plotted in a multidimensional vector space. It's almost like playing chess on hundreds of boards at the same time. Very sci-fi. And this is typically where I stop explaining the technical part. Other than, hey, we store these vectors in a database. So now all of a sudden we have a database with vectors in the answer space. We have possible answers, possible information. So that's the document side. And then of course we have our user side who ask questions or, instruct the large language model. And we too, of course, communicate through language, which an LLM can't understand. So basically when we input something into the LLM, the first thing again that happens is they convert it to vectors. So we end up with two sets of vectors, one in the question space and one in the answer space. And by comparing these vectors, how close they are, how similar they are, we get a sense of, hey, if a vector is meaning, if the meaning of the question is similar to meanings of chunks in the answer database, we might have a match there. And once we've got a match for this vector comparison, so we typically retrieve 1, 2, 3 chunks from this database, and we send that to the large language model, and they can use it to generate a response. This, of course, is still very conceptual, and that's why I really like that the platform that we're using in my course, Mind Studio, can actually show you this in action. You can see it right in front of you happening when you upload a document. So let me show a little example. There we go. So this is Mind Studio. It's basically a full-blown platform where you can build GenAI flows, you can do prompt chaining, you can do RAG. There's a fully implemented vector database in here. You can approach it through APIs, but it's also got like a no-code flow builder. And since this is still session 3, our flows here are extremely basic. And what's really cool in this context of RAG is that you can store your documents in data sources, little databases. So we've got our EU AI Act here. I've uploaded it already, and you can see here on the right hand side, hey, there's 250,000 vectors in this document. And what I think is just really cool is if you click on the source document, it will show you the actual PDF that we uploaded. So including all the layout and all the page structure and things like that. And this being the EU AI Act, I mean, the Publications Office of the EU, they're like content pros, right? So if we extract the text from this PDF, you'll see that it's flawless. But if you extract text from a PDF that has been scanned, so it's basically an image, this will be full of weird characters, white spaces, and basically unintelligible things. So if you upload something to your RAG solution and it's not performing well and it's giving you back gibberish, this might be the reason that the extraction didn't work well, because the quality of your PDF is not up to par. There's not a lot you can do there, although with optical character recognition, you could actually transfer that image into text and see whether that works. But fortunately, this document doesn't have that problem. The only problem here is that, well, the lines are a bit long for the tokenization to take place. So perhaps, writing in shorter sentences might be a good thing, not just for us humans, but also for the text extractor. But we've got like the full text here, and as you can see, this is huge, right? This is actually not really usable in a RAG solution like this. So the next step is that we split that text with a text splitter into chunks. And you can see them right here. So the EU AI Act in MindStudio has, can I close this? Yeah, it has 163 chunks. That's slightly less, I think, than slightly more than the number of pages, because you can see that chunk 163 is at page number 144. And this is where it gets interesting. For instance, when you want to build something with references to sources, if your chunks are not like optimized for retrieving the actual page numbers there where they belong, this might cause some challenges as well. And you might need to kind of dive into that together with your developer or your machine learning expert. But it's just really cool to see, hey, so this is what they talk about when they mean chunks. These are chunks and we can still read them, right? And then where the real magic happens for me and where it's really like LLM meets sci-fi is when we start looking at the raw vectors. Because this is what a chunk looks like in vectors. So basically, if we take chunk number 1, over here, regulation of the European Parliament and of the Council, blah, 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 blah. This is what that looks like in vectors. And to me, call me a nerd, but the realization that this is what we're actually talking to when we're talking to an LLM-based solution. And that the way this works really is like, I mentioned it already, playing chess on multiple boards in like a multi-dimensional vector space, where basically your question as a little vector runs through all these vector layers like a little Plinko board. Mind-blowing still. And this is why I'm probably the most relentless fan and the most relentless critic of LLMs, because in no way does this resemble linguistics or language, right? There's no Grice in here, at least we can't see it. So sometimes I just find myself staring at these vectors. I'm like, where's the intelligence? I can't see it. But then again, I look at the universe and I see all these stars and I can't see extraterrestrial life either. Then again, I'm also like, oh, come on, don't be stupid. This is not what intelligence looks like. It's just a probabilistic text predictor or next best token predictor, even more basic than that. So yeah, I mean, this is not what we philosophize about in our course, right? But this is just me wondering about the nature of LLMs. But yeah, if you want to find out more and also want to find out how to build a RAG solution that's really helpful and interactive, I suggest you enroll for Cohort 6. You're most cordially welcome. And if you feel you want to nerd out, we do have our monthly meetups on Convo Club. And feel free to just, bring everything to the table there and we'll just, linguistically nerd out together. That's it from me so far. Have a wonderful day. Groetjes. Talk soon.